CIET NCERT presents Audiobook of Mathematics for Class 6. Chapter 3. Playing with Numbers.
Part 4.
Page 63. 3.8. Highest common factor. We can find the common factors of any two numbers. We now try to find the highest of these common factors. What are the common factors of 12 and 16? They are 1, 2, and 4. What is the highest of these common factors? It is 4. What are the common factors of 20, 28, and 36? They are 1, 2, and 4, and again 4 is the highest of these common factors. The highest common factor, HCF, of two or more given numbers is the highest or greatest of their common factors. It is also known as greatest common divisor, GCD. The HCF of 20, 28, and 36 can also be found by prime factorization of these numbers, like this. Below this we see the prime factorization of 20, 28, and 36. Thus, 20 is equal to 2 multiplied by 2 multiplied by 5. 28 is equal to 2 multiplied by 2 multiplied by 7. 36 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3. The common factor of 20, 28, and 36 is 2, occurring twice. Thus, HCF of 20, 28, and 36 is 2 multiplied by 2, which is equal to 4. Try these. Find the HCF of the following: 1, 24 and 36, 2, 15, 25, and 30, 3, 8 and 14, 4, 12, 16, and 28. Exercise 3.6. 1. Find the HCF of the following numbers: A. 1848, B. 3042, C. 1860, D. 2763, E. 3684, F. 34102, G. 70105 175, H. 91 112 49, I. 1854 81, J. 12 45 75. 2. What is the HCF of two consecutive A. numbers, B. even numbers, C. odd numbers? Page 64. 3. HCF of co-prime numbers 4 and 15 was found as follows by factorization. 4 is equal to 2 multiplied by 2, and 15 is equal to 3 multiplied by 5. Since there is no common prime factor, so HCF of 4 and 15 is 0. Is the answer correct? If not, what is the correct HCF? 3.9. Lowest common multiple. What are the common multiples of 4 and 6? They are 12, 24, 36, and so on. Which is the lowest of these? It is 12. We say that lowest common multiple of 4 and 6 is 12. It is the smallest number that both the numbers are factors of this number. The lowest common multiple, LCM, of two or more given numbers is the lowest or smallest or least of their common multiples. What will be the LCM of 8 and 12, 4 and 9, 6 and 9? Example 8. Find the LCM of 12 and 8. Solution. We know that common multiples of 12 and 18 are 36, 72, 108, etc. The lowest of these is 36. Let us see another method to find LCM of two numbers. The prime factorizations of 12 and 18 are 12 is equal to 2 multiplied by 2 multiplied by 3. 18 is equal to 2 multiplied by 3 multiplied by 3. In these prime factorizations, the maximum number of times the prime factor 2 occurs is 2. This happens for 12. Similarly, the maximum number of times the factor 3 occurs is 2. This happens for 18. The LCM of the two numbers is the product of the prime factors counted the maximum number of times they occur in any of the numbers. Thus, in this case, LCM is equal to 2 into 2 into 3 into 3, which is equal to 36. Example 9. Find the LCM of 24 and 90. Solution. The prime factorizations of 24 and 90 are 24 is equal to 2 into 2 into 2 into 3. 90 is equal to 2 into 3 into 3 into 5. In these prime factorizations, the maximum number of times the prime factor 2 occurs is 3. This happens for 24. Similarly, the maximum number of times the prime factor 3 occurs is 2. This happens for 90. The prime factor 5 occurs only once in 90. Thus, LCM is equal to 2 into 2 into 2 into 3 into 3 into 5 equal to 360. Example 10. Find the LCM of 40, 48 and 45. The prime factorizations of 40, 48 and 45 are 40 is equal to 2 into 2 into 2 into 5. 48 is equal to 2 into 2 into 2 into 2 into 3. 45 is equal to 3 into 3 into 5. The prime factor 2 appears maximum number of 4 times in the prime factorization of 48. The prime factor 3 occurs maximum number of 2 times in the prime factorization of 45. The prime factor 5 appears 1 time in the prime factorizations of 40 and 45. We take it only once. Page 65. Therefore, required LCM is equal to 2 into 2 into 2 into 2 into 3 into 3 into 5. Which is equal to 720. LCM can also be found in the following way. Example 11. Find the LCM of 20, 25 and 30. We write the numbers as follows in a row. Below this we have a tabular structure with 5 different rows. The numbers 20, 25 and 30 are written on one side, and then we start finding the LCM. The rows have been labeled as A, B, C, D and E. So, LCM is equal to 2 into 2 into 3 into 5 into 5. A. Divide by the least prime number which divides at least one of the given numbers. Here it is 2. The numbers like 25 are not divisible by 2, so they are written as such in the next row. B. Again divide by 2. Continue this till we have no multiples of 2. C. Divide by next prime number, which is 3. D. Divide by next prime number, which is 5. E. Again divide by 5. 3.10. Some problems on HCF and LCM. We come across a number of situations in which we make use of the concepts of HCF and LCM. We explain these situations through a few examples. Example 12. 2 tankers contain 850 liters and 680 liters of kerosene oil respectively. Find the maximum capacity of a container which can measure the kerosene oil of both the tankers when used an exact number of times. Solution. The required container has to measure both the tankers in a way that the count is an exact number of times. So its capacity must be an exact divisor of the capacities of both the tankers. Moreover, this capacity should be maximum. Thus, the maximum capacity of such a container will be the HCF of 850 and 680. Page 66. It is found as follows. Here we have the steps used to calculate the HCF of 850 and 680. Hence, 850 is equal to 2 multiplied by 5 multiplied by 5 multiplied by 17, which is equal to 2 multiplied by 5 multiplied by 17 multiplied by 5, and 680 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 17, which is equal to 2 multiplied by 5 multiplied by 17 multiplied by 2 multiplied by 2. The common factors of 850 and 680 are 2, 5 and 17. Thus, the HCF of 850 and 680 is 2 multiplied by 5 multiplied by 17, which is 170. Therefore, maximum capacity of the required container is 170 liters. It will fill the first container in 5 and the second in 4 refills. Example 13. In a morning walk, 3 persons step off together. Their steps measure 80 centimeters, 85 centimeters, and 90 centimeters respectively. What is the minimum distance each should walk so that all can cover the same distance in complete steps? Solution. The distance covered by each one of them is required to be the same as well as minimum. The required minimum distance each should walk would be the lowest common multiple of the measures of their steps. Can you describe why? Thus, we find the LCM of 80, 85 and 90. The LCM of 80, 85 and 90 is 12,240. The required minimum distance is 12,240 centimeters. Example 14. Find the least number which, when divided by 12, 16, 24 and 36, leaves a remainder 7 in each case. Solution. We first find the LCM of 12, 16, 24 and 36 as follows. Here we have the tabular calculation for finding the LCM of 12, 16, 24 and 36. Thus, LCM is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3, which is equal to 144. Page 67. 144 is the least number which, when divided by the given numbers, will leave remainder 0 in each case. But we need the least number that leaves remainder 7 in each case. Therefore, the required number is 7 more than 144. The required least number is equal to 144 plus 7 is equal to 151. Exercise 3.7. 1. Renu purchases 2 bags of fertilizer of weights 75 kg and 69 kg. Find the maximum value of weight which can measure the weight of the fertilizer exact number of times. 2. 3 boys step off together from the same spot. Their steps measure 63 centimeters, 70 centimeters and 77 centimeters respectively. What is the minimum distance each should cover so that all can cover the distance in complete steps? 3. The length, breadth and height of a room are 825 centimeters, 675 centimeters and 450 centimeters respectively. Find the longest tape which can measure the 3 dimensions of the room exactly. 4. Determine the smallest 3-digit number which is exactly divisible by 6, 8 and 12. 5. Determine the greatest 3-digit number exactly divisible by 8, 10 and 12. 6. The traffic lights at 3 different road crossings change after every 48 seconds, 72 seconds, and 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change simultaneously again? 7. 3 tankers contain 403 liters, 434 liters, and 465 liters of diesel respectively. Find the maximum capacity of a container that can measure the diesel of the 3 containers' exact number of times. 8. Find the least number which, when divided by 6, 15, and 18, leave remainder 5 in each case. 9. Find the smallest 4-digit number which is divisible by 18, 24, and 32. 10. Find the LCM of the following numbers: A. 9 and 4, B. 12 and 5, C. 6 and 5, D. 15 and 4. Observe a common property in the obtained LCMs. Is LCM the product of 2 numbers in each case? 11. Find the LCM of the following numbers in which one number is the factor of the other: A. 520, B. 618, C. 1248, D. 945. What do you observe in the results obtained? Page 68. What have we discussed? 1. We have discussed multiples, divisors, factors, and have seen how to identify factors and multiples. 2. We have discussed and discovered the following. A. A factor of a number is an exact divisor of that number. B. Every number is a factor of itself. 1 is a factor of every number. C. Every factor of a number is less than or equal to the given number. D. Every number is a multiple of each of its factors. E. Every multiple of a given number is greater than or equal to that number. F. Every number is a multiple of itself. 3. We have learnt that A. The number other than 1 with only factors, namely 1 and the number itself, is a prime number. Numbers that have more than 2 factors are called composite numbers. Number 1 is neither prime nor composite. B. The number 2 is the smallest prime number and is even. Every prime number other than 2 is odd. C. 2 numbers with only 1 as a common factor are called co-prime numbers. D. If a number is divisible by another number, then it is divisible by each of the factors of that number. E. A number divisible by 2 co-prime numbers is divisible by their product also. 4. We have discussed how we can find, just by looking at a number, whether it is divisible by small numbers 2, 3, 4, 5, 8, 9, and 11. We have explored the relationship between digits of the numbers and their divisibility by different numbers. A. Divisibility by 2, 5, and 10 can be seen by just the last digit. B. Divisibility by 3 and 9 is checked by finding the sum of all digits. C. Divisibility by 4 and 8 is checked by the last 2 and 3 digits respectively. D. Divisibility of 11 is checked by comparing the sum of digits at odd and even places. 5. We have discovered that if 2 numbers are divisible by a number, then their sum and difference are also divisible by that number. 6. We have learnt that A. The highest common factor, HCF, of 2 or more given numbers is the highest of their common factors. B. The lowest common multiple, LCM, of 2 or more given numbers is the lowest of their common multiples. You were just listening to the audiobook Mathematics for Class 6. Narrator Gaurav Marva. Assistants in production, Soumya Malik. Producer, Vimlesh Chaudhary. Presented by CIET NCERT, New Delhi, India.